Hello class 11th. In the last lecture we have seen the derivation of all the equations of motion with the graphical method. Today we are going to obtain all the equations with calculus method. Here also we will take the initial velocity u, final velocity v, as you have seen in the graph in the last derivation, 0 to t the time and all this thing. These values will be used as limit of the function. So let's see the functions. So first of all, you must understand what is integration, because we are going to use this symbol. To understand that, see here, in the last time we have seen that acceleration, I am giving just example, the acceleration is equal to change in velocity upon change in time. So v minus u upon t minus 0, you can say t2 minus t1 also. I am giving here t minus 0 and the initial velocity is u. So the acceleration is equal to v minus u upon t minus 0, change in velocity upon change in time. And we can also use this as acceleration is equal to delta v upon delta t. Delta shows the change in the value. Delta shows the change in the value. If the time duration is very small, of very fine value, means this time is tending to 0, then what you will say? Then you will say the acceleration is equal to limit delta t tending to 0 and del v upon del t, or the acceleration is equal to dv upon dt, derivative of velocity with respect to time. This is actually called the derivation of velocity with time gives you what? The acceleration. If I am talking the reverse process, then what you will say? What is the reverse process of that? The reverse process of this differentiation is called integration. Differentiation, the reverse process says integration. So here, this is the symbol of integration. This is what? The reverse process of differentiation. What is differentiation? First of all, you must understand. Differentiation is the rate of, for example, of acceleration. We can say the rate of change of velocity. So the very fine value of change in velocity for a very fine time means you are having the data of big, means large value. You have a large value of data, and when you have divided the data into very small part, that's called acceleration. Again, I'm speaking, you have the large data of the velocity and the time. You have divided that data into very small time, so that data is now called acceleration. Now the reverse process. If you are having the acceleration, we are going to reverse. If I will integrate, that's called integration. So if I will integrate this acceleration, so what value we will get? The reverse process is velocity. So integration of acceleration will give you what? Velocity. Same way, many integrations are there we are going to use. But still, how you will say that the acceleration is between some value, because we always take initial value, final value, initial velocity and final velocity from 0 time to some t time. How you will point out the initial velocity, final velocity in this integration? For that, the integration is called definite integration. So that has some limits, where the limit will be written at the bottom of the integration symbol and at the top of the integration symbol. That one, upper one is called upper limit and the lower one is called the lower limit. Suppose we are integrating some acceleration from or velocity from the initial value to the final value. What is initial value? Initial velocity. And what is final value? Final velocity. So you must show that integration of velocity from initial value u to the final value of v. Same way for the time. For the time, the initial value of 0 to the final value of t. Same way we can do further. But the integration, if I am putting suppose u, v, acceleration, time, so of which function you are going to integrate? Like in differentiation you have seen dv upon dt. So the function to derivate with time. So here integration With what function? So here we will say one more factor we will put here. Integration, suppose this is v and there must be dv. Then we will say the integration of velocity with respect to with the function of velocity. If suppose here it is v, integration of v, but instead of dv here there is dt. So then we have to integrate those functions which contains the time. Here velocity is not containing any time factor. So we will split. That is v is equal to u plus at. Now we have to integrate the full factor. Not only v, u plus at. I will show you in the further detail. But suppose there is nothing function here. Integration of 1. Suppose we are using 1 dt. So what will be there? The integration of 1 means constant. That says function itself. So here I am going to show you some list of integration. You must remember. Let's see. Here we are starting the equations of motion by calculus method. So to show the limits, I want to revive with the graph. So just for the limits in the integration, so initial value u to v, so the limit will be from u to v, and for the time from 0 to t. And if you remember that equation was s was having half u t plus half at square. So the displacement will be having the limit from 0 to s. So with these limits we are going to start. So writing in the two different part, like instant or initial you can say, and second final. For the time 0 to t. For the velocity u to v. For the displacement 0 to s. And the time is infinitesimally small. That means delta t is very small, changing to 0. So instead of this we will use dt. So what is acceleration here? So we can write acceleration is equal to, in general it is delta v upon delta t, but time is very small, so we can write dv upon dt, or we can say dv is equal to a dt. So on integrating with limits, so we know that we are having the symbol of integration which is looking like this, integration dv is equal to integration a dt. Now here the function is of v, but there is nothing, so we can consider here it is 1. So integration of 1 dv. And here there is no function of time, so a will be out of the function. And what will be the limit? This is for the velocity. Function is of velocity, so the function is from initial value to the final value. Same way, what is the function here? Time. So the initial value 0 and the final value time. And further what we can write here, integration 1 dv is u to v is equal to, a is not the function of time, so it will be, a will be, this acceleration will be out of the integration. So a is out of the integration from 0 to t. Nothing is right now here, so we can say 1 dt. And if you remember the integration of 1, the function is itself. So what will be here? The v. After integration you must write like this. This is for the mathematics student, very important for the mathematics student. But if you are opting the bio, means except mathematics, so you must have to see what is the process. Integration of 1 dv is v itself, and then you have to write the limits like this, u to v. Same way here, a is out of the function, integration of 1 dt, function itself, so t, and then we have to write the limits, that is 0 to t. Next step is, first you have to write the upper limit minus, then you have to write the lower limit. This is the step. So first, if I am placing, instead of v, I am placing the upper limit. So what will be here? V. Just you have to replace this value with the upper and lower limit. If we are replacing this v with the upper limit, whatever it may be, currently it is v itself, so you have to fill it, or you have to replace it. So on replacing, this is v minus lower limit. What is the lower limit? U. So this will be replaced that. So v minus u. Now next step, the a as it is. Then what we have to write? Upper limit first in the bracket, because the acceleration is already there. The upper limit minus the lower limit. You have to place, means you have to replace this value with the upper value, then minus lower value. Then what you are getting here? V minus u is equal to a into t. Then v is equal to u plus at. This is the first equation of motion. So by calculus method we have done. Again you can see acceleration is equal to dv by dt. You have to start with this function. Then dv is equal to a dt. Then we have to integrate. Integration is like this. And then we have to put the limit. But limit depends on the function. What is the function of here? Velocity. So initial velocity to final. And what is the function here? Of time. Initial time to final time. If this is not the function of here, means it is not having any factor with the function, so it will out of the function, out of the integration. So acceleration is out of the integration because a is not containing any factor with related to time. So we have done this. Second step that you have to remember, that upper limit minus lower limit. This is the condition for the definite integral. Now let's see the second equation. So as acceleration is equal to dv upon dt, this was the starting of the first equation of motion. Same way, v can be written as like ds upon dt. So second equation of motion will be proved using this. It is like velocity is equal to change in displacement upon change in time, or you can say delta s upon delta t if the time is very small. So we can write ds upon dt. Same, we are going to use that. So v is equal to ds upon dt, or you can say ds is equal to v dt. The next step, to integrate. So what we will write? Integration ds is equal to integration v dt. Now you have to put the limits. What is the function? Function of displacement. Displacement starts from 0 to s. You can see here it was starting from 0 to s. Same way, the function here is of time. Time starts from 0 to t. So here is nothing. So we can write here integration of 1 ds 0 to s is equal to, we can say here nothing related to what? Time, but v can be split into two form, that is integration of 0 to t v is equal to u plus at. Now you can see here there is a function of time dt. Now further what we can say here, on splitting 0 to t, u dt, the first part, plus integration 0 to t a t dt. Now copying this here, see here only u. Now u is not having any factor with time, so u will be out. So u is out. 0 to t 1 dt, plus a is not the function of time but t is there, so a will be out but t will be inside. A integration 0 to t dt. T has the factor with time, the function of time, so it will be inside. Rest of them will be outside, like here we have done. So here on integration of 1 ds, you know that integration of 1, the factor itself, s, and the limits 0 to s is equal to u, the function itself again, what? T. We have to put the limit 0 to t is equal to, plus a. Now integration of t dt. If we have seen in the photo that I have shown you, the integration of t dt is what? The t square by 2. Integration of function itself with the time, so it is t square by 2, and then limits 0 to t. Now let's see what is going on. This will be upper limit minus lower limit, so s minus 0. This is u. Upper limit minus lower limit t minus 0 plus upper limit t square by 2 minus lower limit 0, nothing, and a, missing here, a. Then after what will happen? This will be s, this will be ut plus 1 by 2 at square. In this way we have obtained the second equation of motion. Now the time for the third equation of motion. To prove the third equation of motion, we will use this equation again. A was equal to dv upon dt. If you remember, we had proved the first equation of motion using this. But if we will go further with this, we will obtain the first equation. We have to do something different. So what I'm going to do here, I'm just going to multiply, means substitute ds upon ds. Nothing will change. The equation is still same. Then I'm just changing the place. So dv upon ds, I'm shifting ds here, into ds upon dt. We can use the dt is going here and ds is coming here. So now see ds upon dt. ds upon dt, if you remember that ds upon dt is what? V. So we can write it here V. So what you are having, acceleration is equal to dv upon ds into, this is velocity. Now do the cross multiplication and see here, a ds is equal to v dv. Now let's integrate it. On integrating, see, we have to just put this one. Now the time for the limit for the ds. So ds start from 0 to s. Time for the function is velocity. So velocity moves from initial to final. Now what? The function which is related to the function, the factor which is related to the function will be inside, and those who are not related, they will go outside. So here a is not related with s, so it will go out. So a is out of the integration. 0 to s 1 ds is equal to integration v dv u to v. V inside because this is having the factor with the function. So next step, 1 ds, the function itself, means a into s with limits 0 to s is equal to. Now the function and the function itself, both means the function factor and the function. So like here, if you have seen, if it is t dt, so t square by 2. Same way v dv, so v square by 2 and the limits u to v. Now next step, acceleration, the upper limit first, s minus lower limit 0 is equal to, here the upper limit v square by 2 minus lower limit u square by 2. So on solving this, what you will get? V square minus u square by 2. Now take this 2 on that side. So a into s, and this 2 is still into 2. And here what is? V square minus u square, and take this minus u square on that side. So what you will get? V square is equal to u square plus 2as. In this way we have proved the third equation of motion. Let's see for the fourth one. If you remember, for the fourth equation of motion, we had taken s, means displacement, in the t second and the displacement table in the t minus 1 second. So we are going to make this as a limit, displacement in the t second and the displacement as t minus 1 second. Same way. So here, see, this was the step to prove the second equation of motion by the calculus method. Here we had taken the time from 0 to t. Now we will take the time from t minus 1 to t. And the rest of the steps will be same. See, I am going to use the same steps parallelly. Fourth equation of motion I am going to start. So I will use v is equal to ds upon dt equation. This implies ds is equal to v dt. Next step to integrate. So integration of ds is equal to integration of v dt. Now displacement from 0 to s. This will be, actually this is not from 0 to s, this displacement is in a particular second. So I am giving the symbol, this one also, s from the t minus 1 second to the s in the t second. So this will be that. So, and the time here, time from t minus 1 second to t second. If you remember, that limit was here. The same steps I am going to take. Here the time was 0 to t everywhere. I am here taking the time from t minus 1 to t, and the displacement will be from the t minus 1 second to the displacement of t second. So I will give this symbol st in the next step, but I'm showing you how to do this. So let's split this as I have split it here. So I'm just skipping some step. So on skipping some steps, this will be t v is equal to u plus at. So v is u dt plus from t minus 1 to t a t dt. Then here will be 1 ds integration for the displacement t minus 1 to the displacement up to t second. You will be out of the integration. So integration t minus 1 to t dt, nothing is here, so 1 dt, same way, plus integration, this a will be out of the integration, a is not having any relation with that, so a t minus 1 to t and t dt. Now let's integrate 1 ds function itself. So s t minus, this will be greater s upper limit minus s t minus 1 upper limit minus lower limit is equal to u. 1 means function itself, so t minus 1 to t plus a, this t. So if you remember that integration of t is t square by 2, so here I am writing t square by 2 limit t minus 1 to t itself. Now let's put this, will have the different symbol, the distance traveled in the tth second, new symbol. And now u, upper limit first, see here the upper limit is t minus lower limit t minus 1 bracket t minus 1, upper limit minus lower limit, same way here, plus a upper limit is what, t square by 2 minus lower limit t minus 1, so t minus 1 whole square by 2. So stth is equal to u t minus t minus plus 1 plus a t square by 2 minus, on opening is whole divided by 2, it will be t square plus 1 minus 2t. Let's open this. On opening, see here this one as it is, a t square by 2 minus will go inside minus t square by 2 minus 1 by 2 and minus plus 2t by 2. So this 2 will be cancelled, t square by 2 cancelled, minus t plus t cancelled. Let's see what is remaining, u only, u multiplied by 1 plus a in bracket minus 1 by 2 and this is cancelled, only t minus 1 by 2 plus t. Let's take 1 by 2 out, so u plus, on taking 1 by 2 out, 1 by 2 a, this is minus 1, and to compensate this 2 there will be plus 2t. So finally what we are getting, s in the tth second is equal to u plus half a 2t minus 1, the fourth equation of motion. Here I am ending this lecture. In the next lecture we will see the further topics. Till then, be safe, take care, and thank you.